The previous video was the introduction to this chapter. In this video, we'll be discussing about Kössel-Lewis approach to chemical bonding. Two scientists, Walther, Ludwig, Julius, Kossel, and Gilbert and Lewis, worked independently to give us their own versions of the theories of chemical bonding. Let's start with Lewis. So what he thought was, first of all, this is considered to be the cube model of the atom. In the previous, or rather in the second chapter, we had learned about, I think we'd learned Rutherford's model of the atom, Bohr's model of the atom, and then we had learned the modern or the quantum mechanical model of the atom. Lewis gave this model where he thought the atom has a positively charged kernel in the center, and this basically included the electrons as well, the inner electrons and the nucleus. And the outermost area is able to hold about 8 electrons, and these were the outermost. This was basically considered to be the outermost shell of the orbit. So he basically designed the cube model of the atom. Here we have lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. If you notice, lithium has 1 electron, beryllium has 2, boron has 3, carbon has 4, nitrogen has 5, oxygen 6, and fluorine 7. So he gave two reasons for chemical bonding. The first one is the atoms underwent chemical combination to acquire a noble gas configuration. So according to this model, all the 8 electrons, all the 8 corners, if they were filled with electrons, then the atom was considered stable. So according to Lewis, he said that atoms undergo a chemical reaction to gain 8 electrons in their outermost shell or orbit. So the thing is, if you think about it, all the elements of our noble gases, excluding uh, helium, have 8 electrons in their outermost shell. Basically, neon, 8, argon, krypton, xenon, and radon. And all of these are quite inert in nature. But of course, xenon and I think radon undergoes chemical reactions under extreme conditions. But as such, all the other elements of the periodic table tend to undergo chemical reactions to gain the configuration similar to that of a noble gas. So for example, lithium loses an electron to gain the configuration of helium. So he related the configuration of the various elements and the chemical combination. And this basically, this 8 electrons in the outermost shell is the octet rule. The second one is to acquire minimum energy. So when a chemical reaction takes place, or rather when a molecule is formed by a combination of atoms, the energy is decreased. And this in turn means when there is a decrease in energy, that obviously means that there is going to be an increase in stability. So that is, according to Lewis, that is another reason as to why atoms undergo chemical combination in the first place. First is noble gas to attain the noble gas configuration, and the second is to acquire minimum energy. Let's look at what Kossel thought. First of all, he said that in the periodic table, highly electronegative halogens and highly electropositive alkali metals are separated by the inert or noble gases. The formation of negative ions is by halogens, and they do so by accepting an electron, whereas our group 1 elements tend to lose electrons to lead to formation of a positive ion. So this in turn means that when these elements lose their electron, they gain the inert gas configuration, and when these gain an electron, they also will gain the noble gas configuration. So the negative and positive ions are stabilized by electrostatic attraction, and that is the basis for the formation of the electrovalent or an ionic bond. Let's take two examples. Here you have sodium and chlorine. Sodium is an element which is present in group 1 of the periodic table. Chlorine is present in group 17, which means chlorine gains an electron to reach argon's configuration, and sodium loses an electron to gain neon's configuration. So here Na loses an electron to lead to the formation of Na plus an electron, and this electron is accepted by chlorine, and this leads to the formation of the argon configuration, and this leads to an I'm so sorry. This leads to the formation of an ionic bond, or and this is also stabilized by electrostatic attraction. So Na plus Cl minus gives rise to NaCl. Similarly, calcium and fluorine. So here you have the formation of calcium fluoride. Calcium loses 2 electrons to give rise to argon configuration. Let's go back here, right? So when calcium loses 2 electrons, 1 and 2, it leads to the it comes up to the argon's configuration. And so fluorine is a halogen, so it just has to gain an electron to reach the configuration of neon. And that is why when calcium undergoes a reaction with 2 atoms of fluorine, it leads to the formation of calcium fluoride. And this bond, which is formed as a result of the electrostatic attraction between the positive and the negative ions, is called as the electrovalent bond or an ionic bond. Okay, so our alkali metals and alkaline earth metals do not want electrons because they want the electronic configuration of the noble gas or the inert gas, so they lose electrons. On the other hand, our elements of group 17, that is halogens, want to gain the stability or want to gain the configuration of the noble gases, and so they gain an electron, and that in turn leads to the formation of these compounds, and these are also called as ionic compounds. I think we will be learning this about this particular type of compounds and about the ionic bond in detail when we do deal with the second topic of this chapter. But until then, this is the basic idea. So in this video, we had discussed about the introduction of the Kössel-Lewis approach to the chemical bonding. Lewis considered the cube model of the atom, where the inside consists of all the inner electrons as well as the nucleus, whereas the outermost 8 spaces are for the electrons of the outermost shell. And he said that the atoms undergo chemical bonding to reach the configuration of the inert gas, as well as uh, to minimize the energy, which means increase the stability. We also discussed about the causal approach, which basically gave us the idea into the concept of an ionic bond. In the next video, we will be discussing about Lewis symbols.